Other than that, the scheme, the test scheme remains the same. I will demonstrate this. With this example, let's say we have a company that produces steel chains. And the company testifies these chains have a breaking strength of 20 tons, 20 metric tons. That's the carrying capacity of the chain, with some standard deviation here of 1,750 kilograms. Now let's suppose one customer does not believe the quality that we claim and does his own tests. So we now, depending on his results, we ask the question, what is the probability that he finds a breaking strength that is below 19,800 kilograms? And we have two cases. Let's say he buys 200 chains. 200 is a large sample, so we apply the same test we did before with normal distributed values. We use the C-score. Yeah, so, and we test the C-score that he will find a mean value of 19,800. Given the population value of 20,000, because that's our null hypothesis again. Yeah, the real value is 20,000. And that's the standard error, again standard deviation, which is known from the population. Yeah, divided by square root of 200. That gives me minus 1.6. If we have a small sample size, maybe he only bought 14 chains, then we apply the t-distribution, we compute the t-score, which follows the same scheme, with the only exception that we use that this is a smaller number here. And this t-score is larger, and this is tested against the t-distribution. Yeah? So we look in the t-distribution, what is the area under the curve for minus 0.47 for 13 degrees of freedom, because the degrees of freedom is the sample size minus 1. And in the first test we do it again against the standard distribution. So it's always the same scheme. We just have to think about integrate, what distribution do we need to integrate, and what is the test statistic. Okay. So with these 14 samples, he gets a probability of 34% that he will get a lower mean value, which is, yeah, there is a random scatter. There's also a chance to get 3 heads in a row if you throw a coin, if you toss a coin. It's an unlikely event, but still. Okay.